Hello everyone, myself I am Shruti, working as an assistant professor in the Department of Pharmaceutical Analysis and Chemistry. So in this video, I'm going to explain about paraldehyde and the ethyl chloride compounds. So now I'm going to discuss about the paraldehyde. So the molecular formula is C6H12 and O13. So this is the molecular formula for paraldehyde and this is the structure for paraldehyde. So this structure composed of 3 oxygen groups and 3 methyl groups in the benzene ring. So the IUPAC name of paraldehyde is 2,4,6 trimethyl 1,3,5 trioxane. So this is the IUPAC name for paraldehyde. So next we move on to this preparation. So paraldehyde is mainly prepared by treating an acetaldehyde with a strong acid catalyst. Strong acid catalyst, usually a concentrated sulfuric acid. So in this reaction, the 3 molecules of acetaldehyde combine to form a paraldehyde with the removal of water. So now let us see the test for purity of paraldehyde. So first one is congealing range. So the range should be 10 to 13 degrees Celsius. So next one is distillation range for paraldehyde. It should be between 123 to 126 degrees Celsius. So the refractive index is, it should be in the range of 1.403 to 1.406 in 1% of solution of 20 degree at 20 degrees Celsius. So the density should be between 0.991 to 0.996 grams per milliliter. So the acetaldehyde content should not exceed 0.8 ml of 0.5 m sodium hydroxide solution. So for acidity, the acetaldehyde reacts with hydroxylamine chloride to form oximes and the excess acid is titrated, and this value should be less than 1.5 ml of 0.1 m sodium hydroxide solution. So finally the sample should be free from chlorides and also from sulfates. So next is non-volatile material, though it should be less than 0.06 weight by volume. And next one is peroxides. So this peroxides can be identified by titrating with an reducing agent like sodium thiosulfate, which should be less than 2 ml in 0.1 m sodium thiosulfate solution. So next we look at the uses of paraldehyde. So first one is, it is used in the treatment of certain convulsive disorders, and it also have been used in the treatment of alcoholism and also in treatment of nervous and mental conditions, to calm or relax patients who are nervous or tense or to produce sleep. So the next point is, it also acts as a sedative and hypnotic agents. So that means it is used in obstructive practice and used as an analgesic agent. So next we move on to this next compound, which is ethyl chloride. So this is the structure for ethyl chloride. So the chemical formula of ethyl chloride is C2H5NCl. So this is the molecular formula for ethyl chloride. So next we move on to this preparation. So in this step, first it is prepared by the nucleophilic substitution reaction. So in this process, ethanol is reacts with the hydrochloride. So C2H5O is an ethanol in which the ethanol is reacts with the hydrochloric acid to form a ethyl chloride and water. So then the product is then purified by the distillation method. So ethyl chloride is commonly used as an solvent. So now let us see the test for purity of ethyl chloride. So for acidity and alkalinity, the ethyl chloride is first treated with water since it is a hydrophobic. For insoluble chlorides, no turbidity should be observed when tested with silver nitrate. So the distillation range should be between 12 to 12.5 degree Celsius. So there should be no traces of other organic compound after heating the sample. Finally, the non-volatile should be less than 0.01% weight by weight. So next we see the assay of ethyl chloride. So in this assay, it is begun by introducing about 1.5 ml of cold ethyl chloride into a tarred glass toppered pressure bottle that already contains 25 ml of 1N alcoholic potassium hydroxide solution. So immediately replace the stopper and ensure it is tightly secured and weigh the bottle accurately. So next, tie down the stopper firmly, place the bottle in a wire basket and immerse it in a water bath and maintain at a room temperature. So gradually heat the water bath until it reaches boiling. So maintain this boiling temperature for about 30 minutes. So next, after heating, allow the bottle to cool slowly and back to the room temperature before handling it. So once it gets cooled, carefully remove the stopper. And next step, add the phenolphthalein indicator solution and titrate the excess alkali using 1N sodium, 1N hydrochloric acid solutions. So next, make sure it also perform a blank determination for its an accuracy. So remember each milliliter of 1N alcoholic potassium hydroxide solution corresponds to the 64.51 milligrams of ethyl chloride. So this is the assay involved in the ethyl chloride. So once again I repeat. So in this assay, it begins by introducing about 1.5 ml of cold ethyl chloride into a tarred glass toppered pressure bottle that already contains a 25 ml of 1N alcoholic potassium hydroxide solution. So next, immediately replace the stopper and it ensure it is tightly secured and weigh the bottle accurately. So next, tie down the stopper firmly and the bottle should be placed in a wire basket. And this basket should be immersed in a water bath, which should be maintained in a room temperature. So gradually heat the water bath until it reaches the boiling. So next, maintain the boiling temperature above for 30 minutes. So after heating, allow the bottle to cool and slowly back to the room temperature before handling. So once it gets cooled, carefully remove the stopper and add the phenolphthalein indicator solution. And this can be titrated with the excess of alkali using 1N hydrochloric acid solution. So make sure that it also perform a blank determination for its an accuracy. So each ml of 1N alcoholic potassium hydroxide solution corresponds to the 64.51 milligrams of ethyl chloride. So next we move on to the uses of ethyl chloride. So first point, it is used as an anesthetic agent and it also used as a solvent in various applications. Thank you so much for watching this video.